I'm assuming, at least a little bit, that the previous factoring techniques we've looked at are all familiar to you from previous courses. You may or may not have used them recently and may be a little rusty, but hopefully they're going to come back to you pretty quickly. The next technique, factoring the sum and difference of cubes, is possibly something that you may not have seen in prior courses, but fortunately shouldn't be too much more challenging than what we've been doing with the other problems. We have two cases to consider, where either we have two perfect cubes which are being subtracted, or two perfect cubes which are being added together. In the first case, this would end up factoring as a minus b times the quantity a squared plus a times b plus b squared. If we have the sum of two cubes, then this would factor as a plus b times the quantity a squared minus a times b plus b squared. If this is your first time encountering difference of sum and cubes, it's really just sort of committing these two different forms to memory, similar to how you hopefully already have difference of squares committed to memory. Keep in mind that even though we've got some new information to memorize here, the only difference between these two forms is where that subtraction occurs. So for difference of squares, the subtraction occurs between those two terms, and if we're adding two perfect cubes, then that subtraction occurs in the trinomial portion. Otherwise, the two forms are exactly identical to one another. Similar to how we started off difference of squares, we can look at identifying each of our terms in the expression x cubed minus 8 as two perfect cubes. In this case, x cubed and 2 cubed, meaning we can factor this as x minus 2 times the quantity x squared plus 2 times x plus 4. Similarly, for x cubed plus 64, we could rewrite this as the quantity x raised to the third power plus 4 raised to the third power, which would then factor as x plus 4 times the quantity x squared. And since we have the sum of two cubes, now that minus drops into the trinomial portion of this. So we'll have x squared minus 4x plus 4 squared, which would be 16. Again, this really comes down to just being able to identify both the first and second term as perfect cubes, and then committing these two different forms to memory, keeping in mind they're both quite similar. What's changing is just the position of that subtraction sign, depending on whether the initial problem was a difference or sum of two cubes.